So in this problem we're given a sequence a1, a2, a3 and so on is defined by a1 is equal to p and a of n plus 1 is equal to an squared minus 1 where n is greater than or equal to 1. We're also told that p is less than 0. Part A says show that a3 is equal to p to the 4 minus 2p squared. So we're given a1 is equal to p. Next up we need to get an expression for a2. So we can use this recurrence relation here. And it says that a2 is equal to an, which in this case would be a1. So we have p squared minus 1. We then move on to a3, which is going to use an, or a2, which is p squared minus 1, squared, or subtract 1. So if we expand our brackets, we're going to get a p to the 4, minus a p squared and another p squared, so minus 2p squared, plus 1. And we still have to subtract 1 for that, which gets us p to the 4 minus 2p squared, which is what they were looking for. So therefore, a3 is equal to p to the 4 minus 2p squared. Part B says given that a2 is equal to 0, we need to find the value of p. So as a2 is equal to 0, that implies our expression for a2, which is p squared minus 1, is equal to 0. So therefore p squared is equal to 1, and therefore p is equal to plus or minus 1. But we're told in this question, as p is less than 0, that implies that p must be equal to minus 1 for this problem. So you solve it, use the definition that they give you for p, and we get our specific value for p. C says hence find the sum of AR between R equals 1 up to R equals 200. Now, always with these sigma problems, I suggest you start to write out what the terms are and see if we can find a pattern to the problem. Now, we already know that p is equal to minus 1. So if we start to list our terms for a1, a2, a3, and so on, as a1 is equal to p, that is equal to minus 1. We know that a2 is equal to 0, so we can substitute that in. We also have our expression for a3, or we can work it out using the formula, such that if a3 is equal to a2, which is 0, squared, which is 0 minus 1, a3 must be equal to minus 1. But we know if the previous term is equal to minus 1, the next term must be equal to 0, then minus 1, then 0, and so on. So actually, we can see we do have a pattern here. We're going to get minus 1, 0, minus 1, 0 for all of our terms. So if we want to find the sum between the first term up to the 200th term, let's look at what this means. Well, every two terms, if we add them, we have minus 1 plus 0, which is equal to minus 1. Well, if we're going up to 200 terms, all that means is we're going to take our two-term solution of minus 1 and times that by 100, because there are 100 lots of 2 in 200, which gets us minus 100. So therefore, our answer for the sum of AR between R equals 1 up to 200 is minus 100. Moving on to part D then, it says hence write down the value of A999. Well, let's look at our terms here. Because we know that the first term is -1, then 0, -1, 0, actually we can state something about our odd and even terms. And we can say that every odd term is equal to -1, and that every even term is equal to 0. So A1, A3, A5, and so on are -1, A2, A4, A6, and so on are 0. So putting those together, it implies as 999 is odd, therefore A of 999 must be equal to -1 because it's an odd term. And that's how we solve this problem.